Hopefully by now you have a pretty good understanding of how natural selection can lead from a population changing from what it maybe used to be to what it is now because of different selective pressures. Maybe the weather changes and those with longer fur or warmer pelts or some kind of insulation have the ability to survive better. Or maybe the food has changed and those who can access or eat that food or the limited food that is there, they survive and pass on. So that shows how a species can change over time to get a little taller, a little longer, a little faster, a little warmer, whatever those traits might be that give it an advantage. Now we want to look at how can that natural selection that leads a species over time to change, could it lead to new species, and kind of what that theory is. So the first thing I want to show you is the idea, that a species, and I'm just going to use shapes because I don't want to draw animals, you won't like it. If we start with a shape like this, and let's say over time that species changes into a shape that's more like this. You know, some kind of change that allows it to survive or reproduce better. That's what we call a transformation. But if species only ever transformed, we wouldn't get any new species. We would just have like big armadillos turning into little armadillos. And that has changed, or that has occurred. But that's not the only way that this form of evolution or change can happen. The other one is called divergence. So what if we did the same thing? We still start with a square, but this population started to grow into two separate populations, and maybe in one group that population changed like this, and in the other group it could have stayed the same, or maybe it even slightly changed to be like this, just a little more round, still square-ish but a little bit rounded corners. That's called divergence. And that's the kind of evolution we're gonna focus on. That first one at the top can still happen. That transformation is absolutely happening in a lot of populations. But it doesn't lead to new species, it's more just the change of existing species into new forms. And we would consider them eventually new species, because if you took a giant armadillo and a normal armadillo from now, they probably even genetically wouldn't be able to reproduce. But this is the one we're going to focus on, this divergence, this splitting up into new species that weren't around before. And most of the time that happens because of what we call allopatric speciation. That's in your notes, that third bullet down under speciation. I would make sure I underline that term, allopatric speciation. And make sure you know these 3 points. So point number one, there needs to be a physical barrier. So if we go back to the squares, if we've got a bunch of squares living in an area like this, as long as they can interbreed, it's not really a square, as long as they can interbreed, they can mix, they can move between the two populations, any trait that shows up will probably end up being mixed all throughout the population and may lead to transformation, but not divergence. So the first thing that needs to happen is there needs to be some kind of a barrier, right? So some reason these squares on the left are completely separated from those on the right. That could be something like Australia breaking away from the other continents and becoming isolated as an island. It can be something as simple as a canyon, like the Grand Canyon. A big river cuts a valley in between two populations and they can't cross that river. Now they're separated. There are some other separations we'll talk about a little bit later. But for now, let's just focus on a physical separation because it makes things a little bit easier. So, number one, physical separation. For some reason, these two populations can't mix anymore. Two, now we have new mutations or traits that show up, or even just different conditions, so that natural selection acts on one group differently than it does on the other group. So let's say over here, these 4 squares that are separated, and we'll put these ones over here. Let's say in this group, a new mutation shows up and these ones get spots. And that mixes all throughout the population. This would take time. It wouldn't instantly happen to everybody. But let's just say over time that trait gives them an advantage, or maybe not a survival advantage, but maybe it's a reproductive advantage. But either way, that trait spreads around. But remember, because of this physical barrier, that trait can't make it to this other population of squares on the other side. So they can't mix. That trait is now new to the group over there, and it's not over here. And let's say this group over here, they could develop another trait too, you know, whatever this thing is, and maybe that gives them an advantage. And so that trait builds up over there. So the two, because they can't mix, will eventually become more and more and more different. That can take hundreds and thousands and millions of years, but eventually, and that's step 3, eventually these two groups could become so different that even if they ever came back together and they could mix, and you have some with this little thing and you have some that have spots, even if they could mix, like physically mix together, maybe they would either A, not be able to reproduce, they wouldn't be able to produce viable offspring, or 2, they just wouldn't want to. And that's another type of separation, is maybe mating selection or a behavioral separation rather than actual like physical barrier separation. But if these two groups don't interbreed, eventually they will continue to become more and more different until we reach the point where we would consider them different species. And if you remember back to our original definition of what a species is, it has to be able to reproduce successfully and produce viable offspring that can reproduce. So eventually these would become so different they wouldn't be able to reproduce. That's allopatric speciation. We've, over the process of natural selection and some random mutations and different things here, we now have 2 different species that came from that original parent population. That's divergence. That's allopatric speciation. Now, one other type of thing, and this is mentioned briefly in your notes, and this happens quite often in, we think in plants, is what if you had an original plant that was growing, whatever it might have been, and let's say that it had 20 chromosomes. Don't worry about that number, I'm making it up. And chromosomes are just genetic material, but let's say that's what it has. 20 chromosomes. Has to do with your DNA. Well, let's say somehow along the way a mutation happened, and one of the seeds that grew from this plant, for whatever reason, could be a copying error, it could be whatever, but for whatever reason this new plant has 40. It doubled the genetic material. It changed the number of chromosomes. Well, the problem with that is, and in most cases that wouldn't even be survivable, but in this case there are times where you can have too much or too little genetic material and it's fine. But if you now have some of that plant's offspring that have 20 chromosomes and some that have 40, they can't interbreed. That mix most likely won't be viable. And so essentially even though these at this moment might look very similar, essentially at this point by our definition, this and this are new species. Even though right now they may look exactly the same or very similar. But again, over time, the natural selection that happens to this plant or the mutations that arise in this population can't mix to this other group. So just like having a separated island or a canyon between them, there's a genetic barrier between them that doesn't allow them to reproduce. These two groups will eventually become more and more different over time until they lead to new species as well. So that's how natural selection leads to new species. If there's anything there that you're feeling uncomfortable with, make sure you ask, but otherwise, hopefully that kind of makes sense how this could lead to new species.